Hello everyone, my name is Juan and welcome to this week's video. Today we're going to talk about an intro to limits. Okay, so the first thing that we have to talk about when we're talking about limits, it's what's a limit. A limit is basically a prediction of what value of y is a function going to approach as it approaches a certain x value. And second, what uses do limits have? We can use limits in a huge variety of problems. For example, a lot of functions just go crazy when they approach certain values, and limits help us understand them in those crazy spots. Or sometimes we just want to know how does a function behave when they approach positive infinity or negative infinity, and that's it. So now we have this function. It's a parabola, but it has a hole at x equals 2. And we want to know the limits at x equals 1 and 2 just by looking at the graph. So the way we're going to read this is the limit as x approaches 1 of f at x is equal to a certain value. We have to think about what y value are we gonna get as we get closer and closer and closer to 1. As our x gets closer to 1, our y value is gonna get closer to 1 as well. So the limit as x approaches 1 of f at x is equal to 1. Now let's think about our second limit. The limit as x approaches 2 of f at x is gonna be equal to a certain value. So as our x gets closer to 2, our y values are going to get closer to 4 from this side and from this side. As you see here from the right, it's going to decrease until we get to 4, and from the left it's going to increase until we get to 4. So our limit as x approaches 2 of f at x is equal to 4. However, be careful with what I'm saying. I'm not saying that the function at 2 is equal to 4. I am saying that as the function gets closer to 2, its y values are going to get closer to 4, because I want you to know the difference between those two statements. The limits are not always that easy. So we have this function, it goes here and then it jumps and it continues afterwards, and we want to know the limit at x equals 2. What we can do is solve the problem step by step. We're going to find the limit from the left and then the limit from the right, and then out of those two limits we're going to find the actual limit. The limit as x approaches 2 from the left, this negative sign tells you that we're calculating the limit just from the left of f of x is going to be equal to a certain number. So as we get closer and closer and closer to 2 from the left, our y values are going to go closer and closer and closer to 3. So this limit is equal to 3. Now if we take the limit as x approaches 2 from the right, this plus indicates that you're going from the right of f of x is equal to, and the y values as we get closer to 2 are getting closer to 6. So this limit is equal to 6. Now that we have both limits, I want you to think about what value our limit's going to be. Is it going to be 3? Is it going to be 6? Is it going to be the average in between the two of them? No. And that's how the following theorem is going to help us out. It says that a limit exists as long as the limits from the left and from the right are equal to each other. In this example, our limit from the left is different to the limit from the right. The limit as x approaches 2 of f of x does not exist. So that was it for this video. I really hope you guys enjoyed it, and if you did, please don't forget to give it a big thumbs up and subscribe if you haven't yet. If you have any topic that you want me to go over in my next videos, please just write it in the comments down below, and I'll see you all in my next week's video. Bye. Don't worry, be happy.